Right, sorry. I just wanted to go through and make this exam question a little bit clearer. Right, okay, we've got a question. Company receives telephone calls at a random rate, at a mean rate of 2.5 per hour. So that means that our lambda is 2.5 per hour, because remember basically that we have n lambda depending on the time period. Okay, so for A, probability that the company receives for the first one at least 4 phone calls. So X is roughly distributed with the Poisson, and lambda is 2.5. So at least 4 means that the telephone calls are greater or equal to 4. So that means we have to do 1 minus p x less than or equal to 3. And that means we get 0.2424. That's the easy one. Right, now 2. Exactly 3 calls in 15 minutes. So our lambda is over the hour, so we divide that by 4, and we get our lambda at 0.625. So now it's distributed with Poisson with a lambda of 0.625, and we did the probability that x equals exactly 3, and so this time it's PD rather than CD, and that's 0.02177. Great. Okay, now B. Right, find the nearest minute, the maximum length. The telephone can be left unattended, so the probability of missing a call is less than 0.2. Right, so we're looking for the max, and the number of telephone calls is going to be equal to 0, no calls. And we want the probability to be less than 0.2. Right, so we're going to take the probability of all the calls. We're going to subtract the probability that there are no calls. Oh, sorry. And that has to be less than 0.2. Therefore, the probability that x equals 0, there are no calls, has to be greater than 80. Right, now we know that the probability of x being x, any particular value, is e to the minus lambda times lambda to the x over x factorial. Okay, so now we've got our lambda. Now this is telephone calls in a not yet, I'm not doing that part yet. So basically we're looking at this and we say, okay, so we've got our lambda, which is 2.5. So e to the minus 2.5 times whatever the time period is. And then we're going to multiply it by lambda 2.5 to the x, which is 0, over 0 factorial, which is just e to the minus 2.5 t. Okay, remember the t is coming from the fact we've got n lambda. Right, so now we can write that because we want to set the probability. So e to the minus 2.5 t is greater than 0.8 from what we looked at earlier. Okay, so now we'll take logs, and I've got minus 2.5 t is greater than log norm of 0.8, and we'll divide by negative 2.5, so t is less than 0.089. And remember, this is the important part. This is in hours. So if we turn that into minutes, that is 5.355 minutes. And therefore, t is less than or equal to 5, as that's the nearest minute. Okay, and then C, the company puts an advert in the local newspaper. The number of calls received in a randomly selected 2-hour period is 10. And remember, that's our observed example. Okay, and test at 5% significance level whether or not the mean rate of calls has increased, and state your hypothesis. Okay, so we started off with a mean of 2.5. We're testing if that mean has increased at 5%. So we're going to say, right, what's the probability that x is greater or equal to 10? Okay, but we're doing it over 2 hours, because it's 10 in 2 hours. So when we do the test, we are going to do the test with lambda equal to 5. Okay, because that's our n lambda. Okay, and to do it greater or equal to 10, we do 1 minus p of x less than or equal to 9, which equals 1 minus, well, if our lambda is 5, and we go down to 9, that's 0.9682. So 1 minus 0.9682, and that gives us 0.0318. And this is state your hypothesis clearly. So 0.0318 is less than 0.05 at 5%. Therefore, there is sufficient evidence to reject H0, and therefore our mean rate increased. Okay, and that's it.